So today we're talking about relations and functions. The objective is to decide whether relations represent verbally, tabularly, graphically, or symbolically defined a function. So, a relation is a set of ordered pairs. It describes the relationship between the x values and the y values of ordered pairs on the coordinate plane. A relation can be expressed in multiple different ways. Here are some of them for you. When we're looking at ordered pairs, we know that there are x values that come first and y values that come second inside of the parentheses. If we're looking at a table, we know that the input or the x values are always going to be on the top, and the output or the y values are always going to be on the bottom. If we're looking at mapping, our x values go on the left. I'm going to highlight those in blue. And then our y values are those that are on the right, and I'm going to highlight those in red. When we're looking at graphs, these are the things that we have to find a coordinate for, or our ordered pair. For this, let's look at this coordinate right here. We always start at the origin and we go to the right 2 times. And then we go up 3 times. That gives us our ordered pair of 2, 3. And that is our x and our y value. Now, when we're talking about the set of all of our x values, we're talking about our domain. When you are listing out the domain of everything on the graph, it's shown in brackets. These are brackets right here. And then on this one, it's -4, -2, 2, and 5. When we're speaking about our range, we're speaking about all of our y values of the function. We would also list those out inside of brackets, like they do here. Now that we know all of the things about relations, let's talk about functions. For functions, it's very important that we remember that your x's do not repeat. Repeating x's are no fun. So when we're looking at graphs, we're trying to identify in a very simple way if these graphs are going to be functions. Now, I've highlighted the 2 graphs in red, and I'm going to do a very simple vertical line test. I'm going to draw a vertical line from top to bottom of this graph to see how many times it touches in a single line the parabola. If I draw this green line from top to bottom, I notice that it only touches the parabola 1 time. That means it passes our vertical line test, and it is a function. This is a function of x. On our second graph over here, when I draw a vertical line from top to bottom, I notice that it touches my parabola 2 times. If it touches my parabola 2 times, that means my x's repeat, and it is not a function of x. Now let's talk about finding whether or not it's a function whenever you have a table. When we're looking at tables, we're only interested in our x values because we want to see if our x's are going to repeat. If our x's repeat, that means it is not a function. In this table, we have 6, -6, 8, and -8. Each one of those is a different number. So our x's do not repeat, and it is a function. Our x's do not repeat, so that is a function. Now let's go over to our mappings. We know the ones on the left are our x's, and we want to see if those repeat. So I am going to draw a highlighter from my 3 to my 2, because that is the first time. Then my 3 also goes to my 6. My 5 goes to my 6, and my 5 goes to my 8. Now, because this 3 goes to two different numbers, it can't be a function. Because this 5 goes to two different numbers, it cannot be a function. So this entire map is not a function of x. Now that we know all of the basics, let's flip our papers over and try some practice. In our first example, it says Luke is constructing a table of values that satisfies the definition of a function. Which numbers can be placed in the empty cell so that the table of values satisfies the definition of a function? Choose 2 correct answers out of the 5 choices. Now again, I know that my x values go on the top because they're my inputs. My y values go on the bottom because they're my outputs. But I am only interested in my input values. And I need to check to make sure that none of the numbers repeat so that it can stay a function. So let's check these numbers individually. The first number they have is -5. I'm going to look at my boxes. I have -13, 20, 0, -4, 11, -1, and 17. -5 does not repeat as a number, so I can check that off and add it to make it a function. Let's check for -1. Oh, I see -1 right here, so I cannot use this as a function. Let's check for 0. I see 0 right here, so I cannot use 0 as a function. Let's check for 2. I do not see 2 written in the boxes, so I can use 2 as a function. But to be sure and be good mathematicians, let's check that last number of 11. I see 11 right here, so I cannot use that to make it a function. So my 2 numbers that would be correct are -5 and 2. Which of the relations shown represent y as a function of x? Select the correct answer in each row. In the first one, it says y equals -5.4x. That's something we're going to have to use Desmos. So let's pull that up. In Desmos, you put in y equals -5.4x. And it gives you a line. It gives you a straight line. So I'm going to draw a line over here of what it looks like. And then I'm going to perform a vertical line test. If I draw my vertical line through this red line, it only touches one time. So that is going to be a function of x. In the next example, it's giving me a table. So I'm going to highlight all of my x values. And then I'm going to check to see if any of them repeat. In this table, I have -4, -2, 2, and 5. None of those numbers repeat, so that is also a function of x. On the following one, I have a graph. My graph, I can perform a vertical line test through the dots to see if I will touch any of them more than once. I do not. This passes my vertical line test, so this is a function. Moving on, I'm going to coordinates. And again, I'm only concerned with my x values. My x values are always listed first, so I'm going to highlight those in blue. And then I'm going to check to see if any of them repeat. I have -4, -2, 2, and 5. None of those repeat, so that is a function of x. And then again, in my mapping, I know that my x values are on the left and my y values are on the right. My negative 4 only goes to 5. My negative 2 only goes to 3. My negative 2 only goes to 3, and my 5 only goes to negative 3. My x's do not repeat, therefore it is a function. I hope that helps. If you have any questions, please let me know.